Hello everybody, dear friends. Now let's explore the portal itself and see what we get when data from STAAD or other finite element software is uploaded into this unified system. Key benefits and features you will see include unified data storage. Different programs, like STAAD, DLUBAL, or Robot, might use different sign conventions for forces, different coordinate axis orientations, or various ways to define member releases. Our portal accounts for these specifics and converts everything to a consistent internal standard. Once the data is imported, it does not matter which program the model originally came from. Uploading your data. Now let's see how to upload our files into the portal. First, you will create a new project. After that, click the Upload Files button. A window will pop up where you select your exported CSV files one by one. At the bottom of this form, you also have the option to specify which load combinations should be included for the connection design checks. Once you have selected the files and specified the combinations, click Upload. Depending on the size and complexity of your model, please allow between 10 and 90 seconds for the server to process the data, perform necessary calculations, and create the interactive model. Interactive 3D visualization. Once the model is loaded, you can view it directly in your web browser. You have full control to rotate, zoom, and pan the model. You can also easily hide or show individual elements or entire groups. Instantly check connections. Is a connection pinned? Is it rigid? The visualization makes it clear. Easily toggle the view between physical members and the underlying analytical elements, showing their original identification numbers from STAAD. Display elements color-coded by their assigned group, profile type, or other properties for quick identification. Show node numbers corresponding to the original analysis model. Portal interface and tools. Layout. The main screen typically shows the interactive 3D model. A toolbar, located in the top right corner, provides options for visualization, such as coloring by group or profile, toggling between physical and analytical elements, and showing nodes. An interactive table, positioned below of the model, lists all the elements. Interactive table. Each row in this table represents a physical element, like a beam or column segment, between connection points. Columns display properties such as profile, length, name, the type of connection at the start and end, and the assigned group. Dynamic tables. The tables themselves are completely dynamic. You can rearrange columns by dragging and dropping them into any order that suits your workflow. You can also hide any columns you do not need to see, keeping your view focused. Search Builder. Use the Search Builder tool, represented by a binocular, to filter the table content based on specific criteria. For example, show only elements with beam in their name, or only elements using the profile. You can combine multiple conditions using AND or OR logic to precisely narrow down your selection. Visibility. Customize which columns are displayed in the table using the visibility settings. Column groups. Group rows within the table based on a specific column attribute. For instance, grouping all elements by their profile type. Highlighting. The table and 3D model are linked. Selecting a row in the table highlights the corresponding element in the 3D model, and selecting an element in the model highlights its row in the table. This makes it very easy to identify elements. Elements with potential issues identified by the system's algorithms might be visually flagged, perhaps colored red, drawing your attention to them. Editor mode. If the automatic processing made an error, for example, incorrectly identifying a connection type, or if you need to make manual adjustments, click Edit on a single element row to modify its properties, such as connection type or group assignment. Changes are saved directly to the database. Select multiple elements in the table and use the multi-editor function to change a common property for all selected elements simultaneously, saving significant time. Automatic and manual grouping. The portal understands typical connection types and automatically groups elements based on their geometry and end-release conditions, pinned or rigid. Each group name typically consists of a two-letter code plus an integer suffix, like -1, -2. The two-letter code indicates the type of connection or brace, while the suffix increments automatically as new groups of that type are formed. Here are the standard prefixes we use. PB. P means pinned. B means beam. So PB1 indicates the first group of elements pinned to beams. PC. P means pinned. C means column. PC1 indicates the first group of elements pinned to columns. VB stands for vertical brace. HB stands for horizontal brace. C stands for column, used for standalone columns or special column groups. RC. R means rigid, C means column. Indicates a group with rigid connections to columns. RB. R means rigid, B means beam. Indicates a group with rigid connections to beams. RM. R means rigid. M means mixed connection ends. Typically rigid connection where one end connects to a beam and the other to a column. MB. M means mixed end conditions, pinned one side, rigid the other. B indicates connection to a beam. MC. M means mixed end conditions, pinned one side, rigid the other. C indicates connection to a column. MM. Double M means mixed end conditions, pinned one side, rigid the other, and mixed connection ends. One end connects to a beam and the other to a column. Refining groups are initially formed automatically based on geometry, end releases, and the profile type. If the automatic grouping is not perfect for your needs, or if you need to subdivide a group further, perhaps based on different load levels within the same geometric configuration, you can easily do this manually. Use the editing tools or the forces group filtering. Forces group menu. For any selected group, you can access the forces group view. This powerful feature shows the envelope of maximum and minimum forces, axial, shear, and moment, considering all elements within that group and all relevant load combinations. This gives you the critical design forces for that specific connection type or group configuration. Errors identified during review, like a beam intended to be simply supported showing up in a fixed pinned RM group, can also be corrected here by editing the element's properties, which automatically moves it to the correct group, like PB or PC. Fast filtering of critical forces. There is no need to manually sift through thousands of load combinations. The portal automatically identifies and presents the most critical force envelopes, the maximum and minimum values for axial force, shear force, and bending moment for each element or group. It focuses on the forces specifically relevant for connection design. Export options. Our portal offers powerful export capabilities to integrate with your existing workflows and documentation needs. Export to Tekla structures. You can generate a new Tekla model populated with parametric profiles and basic geometry based on your analysis model. More commonly, you can enrich an existing Tekla model by adding the analysis data, such as loads, member identification numbers, and group information as attributes to the corresponding Tekla objects. This integration is achieved using an exported XML file and our dedicated Tekla plugin. Automated reports. The portal generates useful reports automatically to aid your design and documentation process. Excel spreadsheets. These contain structured data, including detailed element lists and critical forces. They are suitable for direct use or for further processing, like importing data into connection design software such as Idea Statica. PDF report. A comprehensive PDF report is also generated. It details the project structure, units used, the grouping nomenclature adopted, the theoretical basis applied, like sign conventions, and includes summary tables of elements and forces per group. This report is ideal for inclusion as part of your official calculation documentation. Exporting the data package. When you are satisfied with the grouping and data verification within the portal, you can export a complete data package. You typically do this by clicking in CSV button. This action provides a downloadable archive file in zip format. This archive contains several key files. Forces. This file contains the critical forces for the physical elements, often formatted specifically for easy import into connection design software. It lists the element identifier, the governing load cases or combinations, and the corresponding 6 force components at the relevant connection end. Physical elements. This is an Excel spreadsheet detailing the project structure. It serves as a clear schedule or bill of materials, listing element identification numbers, length, profile, assigned group, and connection types at each end. Report. The automatically generated comprehensive PDF report described earlier, ready for your documentation. Tekla export. The XML file specifically structured for use with the Tekla Structures plugin, enabling the creation of a new model or the enrichment of an existing one. Streamlining the workflow. The ultimate goal of these features is to efficiently prepare accurate data for the next stage of the design process. Whether that is detailed connection design using tools like Idea Statica, or generating clear project documentation. Grouping elements intelligently within the portal significantly simplifies this preparation. This entire process streamlines the engineer's workflow, eliminating tedious manual data manipulation across multiple Excel files. Everything is prepared and adapted for the next step in your design process.